Welcome to a lesson on normal probability distribution. The area under the normal distribution curve is 1. The area on each side of mu is 0.5. 0.5 on this side, 0.5 on that side, which adds up to 1. Remember, the mean, which is the mu, is 0, and the standard deviation is 1. When you are given x values, you need to transform those into z-scores, and the formula that you use is z is equals to the x value minus the mean, which is the mu, divided by the standard deviation. 3 steps that you need to remember. First step, translate the z-scores, the x scores into z-score. Number 2, you draw the graph. Number 3, you find the corresponding area from the Z table. Let's look at an example that is simplified. Normally, you will be given a word sum, and then you take from the word sum the conditions that you need to write down as statements for your calculation. In this case, I'm going to just give you the conditions that we have. Mu is equals to 80. Standard deviation is equals to 20. You need to find the probability that x is greater than 120. First step, you change the x score into a z score. How do you do that? You substitute into the formula. So 120, which is our x, minus our mean, our mu, 80, divided by 20, and you get greater than 2. All right, so you get 2 from your calculation. Now, the next stage, you draw the graph. Here we are looking at the values that are greater than 2, so it's going into the right hand side. After getting the x value, you go to the table and find the corresponding area that relates to 2. Our z-score is equals to 2, so that's 2.0. So I'll go to where 2 is, move in this direction, and I'm going to get to 0, which is that, because it's 2.00. Okay, and our area is 0.4772. Now, 0.4772 is the area between 0 and 2. Here, from here to there. But I don't need this area. I need the area from here going this side. So what do? I know that from 0 going this side is 0.5. So if I subtract this from 0.5, then I'm going to get the value for 2 going upwards. Therefore, I'll have z is greater than 2 is equals to 0.5 minus 0.4772, and this is my final answer, which is my probability. Let's look at the next example. Using the same conditions, our mean is equals to 80, our standard deviation is equals to 20. Find the probability that x is less than 60. Now we're moving into the left-hand side because it's less than this side. First step, I substitute into the z formula. There, I have 60 minus 80 divided by 20, and I'm going to get minus 1. So this is my z score. I'm looking for the probability that z is less than 1 going this side. I've drawn the diagram like that. Next stage, I go to the table. I'm looking for z is less than 1, minus 1. We don't have negatives in the table, so what do? We go to the positive side, which is 1. This example is also simplified. I'm just looking at 1.00. So I'm going there. My probability is 0.3413. But that gives me the probability from 0 to 1, which is this one. And I don't need that. I need this part. So what do? Like the previous example, I'm going to say 0.5 minus 0.3413. Then I get this shaded part. Now, my probability that z is less than 1 is 0.1587, or 15%. Cool. let's look at some of the tips that will help you. Always remember that the area under the curve is 1, which is made up of 2 halves. When you have a less than area, like the second example that we looked at on the left hand side, all you need to do is to subtract the area that you get from the table from 0.5. When you are looking at greater than area, which is on the right hand side, you subtract the area that you get from the table from 0.5, because the areas that you get from the table are between 0 and the given number. Okay, cool. Now, what if you are given 2 x values instead of 1, which means that you have 2 values and you're looking at areas between those 2 values? Now, here's a tip for you. If the area that you are looking at is on different sides of the mu, one is positive and the one is negative, all you need to do is to add the 2 areas together. But if they are on the same side, maybe both on the negative side, what you need to do is to subtract the smaller area from the larger area. If it's on the positive side, both x values or both z values, what you need to do is to subtract the smaller area from the larger area. So that you need to keep in mind. Let's look at an example that you can see in an exam. I'm going to read that. The time taken to complete a web-based questionnaire is normally distributed with the average time mu of 8 minutes and the standard deviation of 1.35 minutes. What is the probability that a randomly selected person will take between 7.25 and 8.75 minutes to complete the questionnaire? Interpret your answer. Now, here you are given 2 x values. You need to change those x values into z scores. You have the conditions, mu is equals to 8, standard deviation 1.35, and you are finding the probability that x is greater than 7.25 but less than 8.75. Let's start with the smaller one. I substitute my x value into the formula minus the mu, which is 8, divided by the standard deviation, and I'm going to get minus 0.56. So I'm looking at z is greater than minus 0.56. You always maintain the inequality. Okay, you always maintain the inequality. Let's look at the bigger number. I have 8.75, which is my x value. I substitute into the formula that minus 8 divided by the standard deviation, and I'm going to get that, which actually means then I'm looking at the area between minus 5.6 and 0.56. The next stage after changing to a z-score is to draw the diagram. Let's look at the diagram. This is the diagram that we will have. I'm looking at the area between these 2 values. But what do I get from the table? Okay, from the table, I'm going to get the area between 0 and 0.56. Let's look at 0.56. I'm going to get to my z-score 0.5, and I'm going to move horizontally like that, and I'm going to get to 6. Go down. Where the 2 meet, it's 0.2123. Now, this area 0.123 is this area only, okay, between 0 and 0.56. Okay, remember we don't have negatives, so the same area or probability that I got here is the same as from here to there as well. So what do? I then add them together, and then my answer is 0.4246. Now, the last question says, interpret your answer. Always refer back to the question. What is the question asking you? In an exam, always attempt this because it's a mark that you would get with no effort. So to interpret the answer, you're going to say the probability that it will take a person to complete the questionnaire between 7.25 and 8.25 is 42.5. 0.46%. All right, so that is what you would do. Just to give you one quick tip there, is that as long as the probabilities are going outward, so this is greater than or less than, you need to subtract the probability that you would get from the table from 0.5. Hopefully that would help. Take care.